You can't do Eratosthenes with just a small local light source. It won't work on a flat plane for what they say we get when they actually.
What are you talking about? I've replicated it. Every single angle works perfectly.
Yeah, Rich. The Eratosthenes experiment is like Flat Earth 101. I don't know why people even bring that up anymore. It's ludicrous.
Which map or model are we using to test that?
You don't need a map or model, bro. It's common sense.
Oh, okay.
Yeah. Okay, so basically, my original point, though. So basically, I was saying that you cannot. Basically, a sunset would even work on your model, because on your model there is always an apparent horizon. It fluctuates constantly. That means the sun, even in your model, is not actually going below the physical horizon. That means sunsets can work on your model without the curvature of the Earth. Okay? Do you understand that?
I don't. Can you say that again?
Okay, so basically, is Rich here? Do you leave?
Who cares? You're talking to Fiddlebone now.
Oh, okay. So basically, my original point, that's why it was brought up. He resorted to Eratosthenes. But anyways, basically, sunsets, even on a globe Earth, it isn't going below the physical curvature of the Earth. Because even in your model, the horizon constantly fluctuates. So it's an apparent horizon. So the sun isn't actually going behind a physical horizon. It's going behind an apparent one.
Well, you didn't say behind. You said below or through. You said one of those.
Okay, even in their model, basically, it's not going below the horizon if it's an apparent horizon.
Well, it's the model because you don't have one. So by default, it's the model.
I'm talking about the globe.
Yeah. You're a flat earther, right? You don't have a model?
Yes, I am a flat earther.
I know. Yeah. So, but you don't have a model. So the globe model is the model. You said your model or their model.
Yeah, the globe model.
Yeah, that's the model.
What do you mean that's the model?
It's the model. You don't have one. So it's the model of the planet that we live on.
The Globers don't have a model. We don't have a model. Neither of us have.
The Globers do have a model.
No, they don't.
No, we falsified the radius value, so your model is null and void.
Yeah, so
that's not true.
Thousands of maps.
We send radio waves over 10,000 miles. That destroys your little globe.
Yeah.
Okay,
it bounces off the ionosphere.
They have
that would work, but the ionosphere can only reflect 40 megahertz, but we send them over 900 megahertz.
What sort of license do you have?
Straight through going to space.
Can you tell me what 7.3 means?
What's that?
No. Can you tell me what 7.3 means?
In what context?
So, you don't know anything about radio then?
No, okay. I'm asking in what context.
Well, I mean, if you knew even a single thing about radio, like level 1 stuff, you would know what I mean when I say 7.3.
You don't need to know all this terminology to know how radio.
I mean, it's like basic 101 stuff.
Bro,
you just got ad hoc in me?
Terminology, no logic.
Yeah, I mean, I guess you could say that's an ad hoc, sure.
Yeah,
maybe it's an insult.
Explain why the radio waves go 10,000 miles.
I just said it bounces off the ionosphere. I gave you the answer.
Okay, so what is the frequency, the maximum frequency that the ionosphere can reflect?
Yeah, like I said, it does bounce off the ionosphere. So, I mean,
I said, what is the
maximum that's the answer.
WordSalad, I'll ask him a question. Okay, Fiddlebone, you go to Google and you look up radio waves sent to the moon, like to measure it, and it will literally tell you, point blank, they have to have a megahertz of over 40 to penetrate through the ionosphere to get to the moon.
Is that the same as bouncing off the ionosphere?
Okay, can I finish, please? Can I finish?
No, it's not the same thing.
Anything above 40 megahertz will penetrate through the ionosphere. You have to have it below 40 megahertz tops in order for it to, quote-unquote, bounce off the ionosphere. That's just fact.
Right.
That's your model.
Yeah, use Google. You seem to think it tells you the truth about everything.
Yeah, use Google. Just look up radio waves sent to the moon.
What?
Hello?
Did you say
What's that?
tropospheric ducting?
Does the ISS exist?
What does
Yeah,
that
I
have
think
to do with anything?
But
I'm
how is
just
that
asking a
relevant?
question. It does
How is
exist?
that relevant? How is that relevant?
That's irrelevant.
Because it's related to radio, because you could talk to the people
That's a red
in the
herring
ISS.
fallacy.
Red herring
radio.
fallacy. Stop it. Stay on topic. We're talking about radio waves.
This is
that go
completely
too
on
far.
topic.
Okay, tell me how.
On topic. It's because it's related to radio.
Okay, expound.
Because if you use a $30 Baofeng radio, you could speak to the people in the ISS.
Okay, yeah.
What does that have to do with anything?
Well,
Yeah.
I'm just asking you. Yeah, I mean, maybe it's a
How does
side
that prove
conversation, but it's not a red herring.
But how does that have to do with anything of sending radio waves over 10,000 miles?
Because it's judging your knowledge of radio waves.
That is completely irrelevant. You apparently don't know anything about it because you think that they can, 900 megahertz can bounce off the ionosphere.
So once again,
literally.
does the ISS exist? Yes or no?
Fiddlebone.
That is completely
You're
irrelevant. I won't
diverting
answer
your-
that.
It's completely irrelevant. Can you answer the question
You're
though?
scared and you're running
Can you
away.
humor me?
You're scared
humor
of
me?
me?
It does
We don't-
exist.
No, you
Now,
can't.
can we get back to our point?
Fiddlebone,
You're not gonna answer the question.
I said it does exist. It does exist.
Go to Google.
How does it
Back
exist?
here. It does exist.
What's it?
Yeah.
How is it staying in the air?
Oh yeah, you want to talk about it? It actually destroys your model.
Okay.
So actually, when they launch the ISS, they account for a stationary Earth. Like you can literally look at the equation.
Because who?
They account for a stationary Earth-centered
Fiddle,
Earth.
don't let
That's
him
not the
speak.
question of how it stays
They
in the air,
account
though,
for
does
the
it?
angular momentum.
You asked how. Let him speak, Fiddlebone. Shut your mouth,
He's not
please.
answering the question.
Shut your mouth, please. Let him speak. Let him
Well, answer
speak.
the question then, if you're gonna speak.
Then you can tell him that after he's done. Just let him
Go ahead.
speak.
Hurry up.
Okay, so when they launch the ISS and when they launch satellites, they account for Earth-centered Earth fixed coordinate system. They account for the angular momentum of a universe rotating around a stationary Earth, giving you real inertial forces, which in your model, there are fictitious forces, so you wouldn't have to account.
Because you don't have a model. So you have to say the model.
Fiddlebone.
Whatever.
Please
Stop
put yourself
diverting.
on mute.
Go
It's
ahead.
not. It's important to point out. It's true.
That's just semantics, okay? And yeah, so when they account for the angular momentum of the cosmos rotating around stationary Earth, they account for real inertial forces, which is not possible in your model either. They also account for
your model. It's
curved
the
paths.
model.
Bro, the globe model. Now, please listen.
Okay,
The model, yeah.
In the model, okay, I'll say it.
Yeah.
In the model,
There you go. Better.
there are no curved paths in space-time. Like, everything moves in a straight line in an orbit. And it's just following a path in the curvature of space-time. So you would account for a straight path, but they account for curved paths. So that all that the ISS does is debunk heliocentrism. Because they account for things that
how's it staying in the air? How does that answer my question?
What?
How's it staying in the air?
Yeah, because it's
actually ether drift.
Force, bro. With the
Oh,
ether.
yeah.
Hey,
The ether, is that
The
what you
real
just said?
inertial force from the sky, according to the equation, keeps it in orbit. Okay?
Okay,
So
round one
it's
is
just
over.
floating.
Look at the
It's
equation.
infinite energy. It's just floating up there.
Can we get back to radio waves?
Well, hold on. You just said it's just floating up there. That's your answer?
I said
You guys, hang on, just a point of moderation really quick. First, guys, I would try not to interrupt as much. And you guys were on radio waves, and all of a sudden you just said, do you think the ISS is real? Which
Exactly.
he was asking you a specific question. He was asking you a specific question about frequencies and what frequencies pass through the ionosphere and what frequencies pass or bounce off of it. And you said, do you think the ISS exists?
I'll steelman Fiddlebone's argument here. So basically what he's saying is, if you believe that radio waves cannot bounce off the ionosphere or whatever, like basically for some reason he's bringing up that because we can send radio waves to the ISS, that means the ISS exists and somehow it has to do with radio waves. But we're saying the ISS does in fact exist. It can easily exist, and the very fact that it does exist debunks heliocentrism. Okay, so now back to radio waves. Fiddlebone, can you look up on Google real quick? Google what, like,
I'll Google it.
radio wave sent to the moon. Okay, radio wave sent to the moon. Look that up.
Radio wave sent to the moon. Okay. Radio wave sent to the moon. What do you want me to look up?
Yeah, basically look up megahertz of radio wave sent to the moon or whatever. And it will basically tell you...
Megahertz of radio waves? That's not what you told me to Google. So now you want me to change my Google. Megahertz of radio waves sent to the moon.
My Google has Gemini, so I'm not sure if it would show up in the same way.
Yeah,
but,
I see it.
Yeah.
Okay.
So you look at you just quick search on the information of it. I'm not sure how exactly you need to get to it. It might be different. I might not be remembering the exact wording, but basically it will tell you point blank they have to send it with a frequency over 40 megahertz in order to penetrate through the ionosphere. So basically the ionosphere cannot reflect or make a radio wave bounce off that is above 40 tops. Okay,
yeah,
so
ideals.
So are you denying that people send things to the moon? Send radio waves to the moon and get responses back? Are you denying that people get responses back from the moon?
I'm telling you what.
So you admit that exists, right? I just want to make sure. I just want to get an understanding of what you admit exists.
I'm not saying that they exist. Stop trying to divert. I'm basically
saying it doesn't exist, so people don't get responses back from the moon.
Listen. I'm saying.
I'm trying to understand your worldview here, buddy.
But this is absolute audio chaos. Hang on, stop. Can you guys just go one at a time? Just have like one person say something, then one person ask something. You know what I mean? Just try to go one at a time and not talk over each other.
So Kwon,
it's kind of
we sent radio waves to the moon and gotten responses back?
Trying to convert the argument away. That's all he's doing.
There's a random third person interrupting.
Having a discussion.
Random third person interrupting.
Yeah, alright, everyone stop again. Look, even if he is doing that, Pierre, I mean, we can't have audio chaos. Even if he is doing that, still, everyone should just let the other person finish, and then you can address. If you think it's a straw man, wait till they're done talking.
Kwon, I'm trying to understand your worldview here. Have we sent radio waves to the moon and gotten responses back? Yes or no?
Okay.
No, we have not.
No, we have not. Okay. So in that case, is it possible that we can bounce things off the ionosphere because it's impenetrable?
Okay. So can I answer now? Basically, my point, I'm not going to divert, I'm not going to go off on this red herring trail. Okay, my point is that your model, point blank, out in the open, admits that a megahertz above 40 will not reflect off of the ionosphere. And I was giving you a source, an easy source that you can just Google and find that information real quick. Okay, you don't need to go on any website or anything.
Okay, so you're saying will megahertz above 40 bounce off the ionosphere? Is that what you want me to Google?
Okay, yeah, go ahead.
Okay, let's see.
Yeah, and so I'll just tell it while you're
a 40 megahertz signal will bounce off the ionosphere under certain conditions.
Okay. So
the ionosphere
above.
You're asking me to. Okay.
I said above.
Okay.
Because
I said above 40 megahertz.
Yeah. Okay. Because what we have actually sent is radio wave of 104 megahertz.
Right. Frequencies above 40 megahertz can still bounce off the ionosphere, but they're more likely to penetrate it, passing into space.
Look up a 100 megahertz. Look that up.
Yeah, they actually have a thing with the ionosphere clouds. So it'll be denser sometimes in some spots, and you guys are talking about that, or?
Wait, but
what 300 megahertz typically.
The ones that we sent to space are 111 and 198 megahertz.
Okay, now look up 400 because we've done it 400. Look up. You can even go to LoRa, longest distance world record.
Wait, how does this prove your point?
Okay, so let me explain how it proves our
900 megahertz were sent
over. To penetrate it, passing into space. That's what it says. Isn't that the
exactly.
Whole point?
So can I now explain what this experiment is? So basically, you have something on the water. Okay, this is done on the ocean, and it is basically just 15 meters off of the ocean surface. 15 feet off of the ocean surface, and you send it out to a target. Okay, that is just like 6 feet above the surface of the water. 10,000 miles. Okay, let's just give you the benefit of the doubt. I think the more widely known and accepted one is 2,100. So that's 2,100 miles. And it directly goes to the target. There is no skip zone, no nothing. Okay.
So I can explain the skip zone. So
with the 900 megahertz.
With 900 megahertz? Show me that.
look up LoRa longest distance world record of transmission. That one was over 900 megahertz. But yeah. So anyway, even if let's grant your little ionosphere that can somehow magically reflect any frequency, so
Not magic,
there should be
okay.
But yeah, if it can reflect above 40 megahertz, it's magic. But yeah, so if you are going to bounce something, so like draw a line from a globe bouncing off and then coming back down. So it's like a triangle. So what's the area in the triangle? It's called a skip zone. So it's where the radio wave would not be received on the Earth. Okay, so the military knows that there's a skip zone, so they calculated it where it would be when they send them, and they place people where the skip zone would be, and they receive it, which means that it's not bouncing off the ionosphere because if it was, then there would be a skip zone, and people in the skip zone would not receive it. They've placed people the entire way, and they all received it, which means it's going horizontally. So that completely destroys the globe.
Yeah, so you can deny it or whatever, but yeah, you're just spiraling then.
So because of this, the Earth is flat? That's the conclusion you come to?
Okay, can you debunk that, bro?
No, I'm just trying to understand the flat Earth brain.
Well, think about a line going horizontal. If you send it horizontally, of course, if it's a flat plane, you'd receive it the entire way, like we experienced.
And if
let me ask you another question. Do you vote?
Hey, can I ask you a question?
That's not anything.
Mind if I
hear it?
I don't care to vote because it doesn't really matter.
So you don't
I
vote?
might
Good.
vote sometimes. Yeah.
That's not relevant.
No, good. I just want to make sure you don't vote.
No, that's ad hominem.
destroyed.
That's on ad hominem.
Can I bring up something? If you don't mind, who's that, Grandpa? Fiddlebone asking about
I
vote.
thought you said 10,000 miles. This is 830 miles.
No, I was giving you an example of 900 megahertz.
Yeah, but you said it went
You can go to
10,000 miles.
ARRL.org. ARRL.org. That's where
Wait,
they
but
have
what
a
did you
bunch of
say?
them.
Didn't you say 10,000 miles? I'm looking at it now. 830 miles.
Different
I said 900 megahertz.
No, you said
And
it went
then
10,000 miles. That's what you just said.
I was the one who said 10,000. That's on a different website. I believe it's
I was giving an example because he said that. He was like, they don't go.
They're just got you in a lie, huh?
No. I
You
said
just lying to the room here? Trying to attempt to make arguments?
I was the one who said it was 10,000 miles. It's a different
why would you say that?
experiment on a different website.
Why would you say it's 10,000 miles?
Bro, I'm literally telling you right now.
I'm looking at you. You said look up Laura, right?
No.
And you said it's 10,000 miles. Yeah, you did. Yeah.
No.
You said look up Laura. It's 10,000 miles.
Listen to me.
Right,
Word Salad said his experiment with 900 megahertz was LoRa. I was referencing to a different experiment. I believe the website is ARRL.org, where there are radio wave frequencies with, I believe it's 104 megahertz, and they have sent them 10,000 miles. And I gave you the benefit of the doubt and said even if it's only 2,100. Okay, I'm giving you the benefit of the doubt.
How's that the benefit of the doubt if the record is 830?
No, that's a different experiment, brother. I was referring to a different experiment.
This is the world record, apparently.
No. Okay.
World record for megahertz, I believe.
Yeah. Yeah, depending on the frequency, the altitude, and stuff like that. Okay, because it's the longest distance. I think direct transmission without bounce. I don't remember, but it's different than regular transmissions that they send in the military and things like that. And also, this one would send
Yeah, they do it all the time. Look up arrl.org, and you will find.
Look, I'll post the distance records in the chat. It's a PDF file.
Yeah.
But if you just click it, it'll go to a website, and you guys can look at the distance records, and it tells you the waves.
Yeah,
the
they're way
distance and the
over
propagation.
100 miles. Like, that's not the world record of, like, the farthest. There's radio waves, just, you can find them anywhere, like, way over 800 miles.
But even if we were to grant them that is the world record, it still destroys the globe because it should be blocked at less than 20 miles. It was 15 feet above the water.
Let's even give them 200 miles or 400 miles. Like, that's still only, 400 miles is only half of 800. Like, brother.
Yeah, it should be blocked at 20 miles according to the math. You can do the math. 15 feet above the water, sent horizontally.
And, like, every time we bring this up, people try to obfuscate to another topic or walk away.
Well, you could articulate the argument a little more effectively if you rule out skip and bounce earlier, where you say, like, look, you don't have that because anything lower than this, because obviously above 30 to 300 is what they say pierces through, right? So, like, if someone's claiming that, oh, you have a 144 megahertz that goes 2,000 kilometers, that's problematic because you can't claim ionosphere bounce.
That's dishonest, brother. That's it. That's if they're dishonest and don't know about radio waves. So that if they're dishonest or don't know about radio waves, and we give them the benefit of the doubt, then we can switch to something else that destroys their position along the same line. Like,
okay, so in the source you posted, right, with the records, look at the mode on the left. Do you see that?
Yeah, okay, that's
Aurora. Do you know what that means?
That's their explanation as to why it does that, because they have...
okay.
Yeah,
so once again, you're just walking away from the answer, saying, oh, it's a big lie. It needs to penetrate. Do you know what it means by Aurora mode? Do you know what that means?
Aurora mode?
Yeah. Do you know what that means?
I've familiarized myself with that in the past, but I'm not.
Okay, let's hear it then. Let's hear what the Aurora is.
I said I don't recall it.
Oh, okay.
You can remind me.
You're basing your worldview off of things that you just have no idea about. You know.
Is your entire argument an appeal to credentials, which is you don't have the credentials to make any argument? Don't interrupt me.
Aurora mode is. During auroral events, charged particles in the ionosphere near the magnetic poles scatter VHF signals, allowing contacts over 1,000 miles, especially in polar regions.
Yeah, so first of all, we've done it 2,100 miles, bro. First of all. But also, that's...
Is 2,100 over 1,000?
That's their explanation as to why we receive those, but they are not realizing that they are making a huge contradiction, because according to their model, you cannot duct or
to the model.
Ionosphere
you don't have the model, remember.
They're not accounting
about ducting. The ducting still has a skip zone, and they place people on the skip zone, and they still receive it, which means there is no skip zone. Thanks for playing.
So you pretending to understand about radio means
bro, you haven't even looked at what the military do.
You've never looked at the world record. That this thing that you sent in the chat is 2,178 kilometers.
Yeah.
So show me one that's more. Show me one that isn't on this list.
Yeah, no, that debunks your position, bro, because you have to...
How does that debunk? It's during... It was an Aurora event.
Phil, but you've got to have some forbearance. Every time anyone talks, you immediately interrupt them. Just go one at a time.
Bro, so basically that's their explanation as to why it did that, because they could not think of any other way to explain it on a globe Earth. Okay, that's not actually what they observed. That's what they assumed. Okay, so the thing is, it contradicts everything else that they admit about radio waves, that they cannot duct without there being a skip zone, which we do not, which we receive radio waves in those skip zones, and then you cannot have them reflecting off the ionosphere with a megahertz of over 40. They contradict themselves. You can obviously tell it's an assumption because they don't know how else to explain it. It's not their observations or their measurements. They are assuming that because they already have this presupposition that the Earth is a sphere.
You say a bunch of bullshit, and then the answer comes back at you. Then you go, "Oh yeah, oh, but they're just making that up. You're just coping and seething right now."
Oh, man.
Yeah, that's literally what's happening right now.
Maybe you should actually listen to what he said. He said that their explanation.
Yeah, he just said they're making up an explanation because they don't know how it happened on a globe Earth.
Yeah,
that's what he just said.
Yeah,
that's called
and we can
coping
prove
and seething.
they made it up. It's like saying that the reason that the cookie disappeared is because an alien from outer space came. It's like saying that, but yet you can prove that there is no alien from outer space.
Coping and seething. I mean, you want the world to be flat.
All right, we're not. Stop for a minute.
Yes, sir.
Listen, we're not going to do ad homs, nonstop interrupting, audio chaos. We're not going to do any of that. We don't need to ad hom each other. We don't need to insult each other. We just go one at a time. You can make a point. Someone can address the point. You just have a regular conversation. This doesn't need to be that serious. It doesn't need to be that personal. You guys can just talk to each other, right?
Okay. Yeah, can I break it down? Can I break it down just bit by bit to like... Let me break it down. Okay, so you have the model, the globe model. Its claims are that above 40 megahertz, a radio wave does not reflect off of the ionosphere. It penetrates through it. You also have tropospheric ducting, okay, which means there would be a skip zone. Because as it goes into the atmosphere, into the troposphere, it ducts on the troposphere. It comes back down to the Earth, and there is a skip zone. That means an area where no radio wave will be detected. Okay, so now you have these people. They do these experiments. They send these radio waves. And so they do not take into account that radio waves cannot reflect off of the ionosphere with the megahertz over 40. They also do not realize that there is no skip zone. So because they think in their minds just like you, the Earth must be a sphere. It has to be a sphere. So there must be some explanation to this other than the radio waves are going horizontally directly to the target. So it must be ducting. It must be reflection. It must be diffraction. They can't say anything else but that. Otherwise, they are basically admitting that it is going horizontally directly to the target. So they're not lying. They're just saying, oh, the Earth is a sphere. It must be this ducting, this reflecting. So they're not being dishonest. They're just trying to cover up because they don't have any other way to explain it, and they are just forgetting about.
Okay, stop yapping, dude. Okay, you don't have to go on a 5-minute monologue. So if you're not,
I'm about to finish. I'm about to finish. They're not lying. They're just not taking into account the contradictions that come with those claims.
Okay, great. If you're not lying right now, go outside, transmit on your radio, and talk to someone that's 10,000 miles away.
Okay, so I'll answer that. Okay, so first of all...
No, you don't have to answer it. Do it, record it, and show me.
No, I'll answer that and show you how I can't.
What do you mean, no? Yes, you would have to do that if you're not lying. If it's so easy, if the Earth is flat, and you could just speak on a radio and talk to someone 10,000 miles away, go do it right now.
Not attenuation.
Record yourself and show me.
Let me tell you how I can't. Okay.
So you can't do it. Why not?
Let me tell you, I can't.
Okay, let's hear it.
Why are you listening for one?
The entire globe model depends on you taking someone else's word to know that it's a globe.
Okay, that's great. Thanks for the interruption. I'm talking to this other guy, though. Thanks.
Billbone, let me answer that.
Okay, it's an open panel. It's not a one-on-one. If you wanted a one-on-one, we could do that, but it is an open panel. The entire globe model depends on you taking someone else's word for it, but now you're saying that he can't do that. So what you're doing is special pleading.
It's actually not taking someone else's word for it because I could see a sunset and I could see the stars rotating differently in the northern and southern hemisphere. It's actually not about taking other people's words. I could see it with my own eyes.
I already
And it's
destroyed
something
star
that
trails
most people
earlier,
realize
and
by the
you
time they're like
destroyed a
5 years
sunset
old.
Once again, we need to go one at a time. Word salad, Kwon. Let him finish his point.
Okay,
Okay,
sorry.
So yeah,
Did you say?
Wait. Grandpa's making a point. He said, I already disproved that because I can see a sunset. God.
Okay.
Yeah, no, I mean,
So
you're saying taking people at their word. Most people, by the time they're 5 years old, come to their own conclusion that we're not on a flat Earth by looking at a sunset, by seeing the stars rotating differently in the northern and southern hemisphere. There's a bunch of very obvious observations that people make.
I can destroy those all. I've already done it.
But
I destroyed them
tell me
earlier.
why
Were
you
you
can't
on
do
here?
the radio thing? Can you?
All right,
Can
yeah,
you
let me answer
why you can't do the radio thing?
Let me answer that.
Okay.
Okay. So there is a reason they send them on the ocean in both models. In both models, because there are obstructions. There is elevation on the land, brother. Like, that's dumb.
Okay, so why can't you do it? So go to an ocean.
There is
talk to someone 10,000 miles away. Do it.
Elevation. There's a reason they do it on the ocean.
So go to an ocean and do it right now.
I can't just go to the ocean, bro, and do it. I also have to set up a target 10,000 miles away.
Yeah, so do it.
Yeah. And I have to have a clear path. I can't have anybody messing with the like. I would have to set up.
Okay, so how about this? Show me someone doing it.
Yeah. Okay. I just showed you independent sources.
Show me. You showed me independent sources. Where every link I saw had 800 miles.
Okay.
So post it again
on ARRL that you saw.
I was looking at that.
2,100 miles. 2,100 miles.
That's 2,100 kilometers, right?
Okay.
Which is about 1,000 miles. Yeah.
Okay.
Okay, so you're wrong there. You're lying right now.
Oh no, I was mistaken.
Okay, you don't need to accuse him of lying. If he got something wrong, you can say it's, be good faith. Maybe he got it wrong. To call someone a liar is a very specific thing. You don't know that he was intentionally trying to mislead you. Yeah. We don't need the ad-homs, Grandpa Fiddlebone. Yeah. We just not have that.
Let's say 1,000 miles. I'll grant you that. How do you explain that they are sent 1,000 miles?
I just did, dude.
No,
I just did. I posted the Wikipedia article for you to read if you're interested.
Okay, you didn't tag me. I don't think you tagged me.
Okay. I'll tag you right now.
Shouldn't there be a direct answer to that, though?
Yeah, I explained that it was during an Aurora event, right? And then I read you what that does.
I already told you. Yeah,
and then you just said that doesn't exist and they're making it up. I know. I recall the conversation we just had.
Straw man. I will answer again.
You literally just said they made up something to account for something that can't happen.
I will answer again and let me show you again. I will answer again in basic language.
Go ahead.
Basic English language. Okay. So, they did not account for the fact that there are contradictions that come with their claims, such as it cannot reflect with a megahertz over 40, and if there was a skip zone caused by this aurora, because there is a skip zone, there would have to be, they do not take into account that there's a contradiction because we receive radio waves within those skip zones.
Okay, so once again, you just admitted what I said. You said they just made it up and they didn't account for it and they just came up with an answer.
They did not account for it. They didn't think of it, bro.
Oh, okay, so why are they saying it was because of an aurora? Why are they saying that? Because they made it up, right?
They are assuming that the Earth is a globe, and so they are thinking the only explanation for this is either that it's flat, but they're thinking, oh, we know it's not flat, so the only explanation for that would be aurora ducting.
Okay, so in other words, they're just making up a reason, right?
No.
Exactly what I just said. No, they're not.
They are not making up a reason. I believe that
so it's a real reason?
Most people believe that tropospheric ducting and all that is a real phenomenon. Okay, but they do not take into account that it is impossible to duct over that length without there being skip zones. And so, but we receive radio waves within those skip zones. They do not take that into account. So they are basically making an assumption that's biased, not malicious. It's just biased.
Can you address why is there no skip zone? Like, why when we place people in the skip zone, why do they receive it when that shouldn't happen on a globe?
All right, I'm back. What were you saying?
Okay, answer his question about why do we not have a skip zone?
Like, it's a requirement on the globe. If you're going to have your little aurora ducting, there would be a skip zone, and they've placed people along the skip zone, and they receive it, which means that there is no skip zone, so that means that it cannot be ducting.
Okay.
So do you have an explanation for that? You can say, no, I don't.
You're just saying things. I mean, yeah.
No,
do you have any source? Do you have any proof or anything?
Bro, the fact that you cannot just address it and say, I'll look into that, shows that you're completely biased.
So I literally Googled everything you told me to Google, looked up everything you told me to look up. What am I looking up?
Yeah.
No, but can you repeat that, what you're being asked? Because they're asking a very specific question. Could you repeat that just to demonstrate that you heard the question?
I'm able to recall conversations because this guy clearly can't. But he said, they say there's a skip zone, but it doesn't exist because people under the skip zone are able to receive radio transmissions, which completely debunks the Aurora explanation. Is that okay? Is that a good summary?
No.
And can you demonstrate that claim before asking him a question that presumes that claim? Do you have something that demonstrates that claim?
That claim of what? What do you mean? What did I just claim there?
That's a specific claim. He says there's no skip zone. They just say that
there's him for a source on that. Anything you want me to look up?
You're interrupting me now when I'm trying to moderate the conversation.
You're doing a really bad job moderating. You asked me to recall something.
I'm trying to moderate the conversation so that way you guys can just talk, right? And if, as I'm doing that, you're interrupting me to add more chaos into it, we're not able to have a conversation. If you want, I can mute one person, then someone can talk, then I can mute the other person can talk, but this problem only seems to be happening on one side. So, if Kwon can demonstrate his claim, because he's asking you a question which is based on a claim which you're saying you don't believe the claim, if he can demonstrate that claim, then he can ask you that question, and then you can answer in good faith, because that's what you're asking for.
Yes, thank you. I mean, why do you need to repeat what I'm asking for? I don't get it. How is this moderating?
Because he didn't understand you were asking that, and then you were interrupting people nonstop and ad-homing them. Go ahead.
You interrupted me as I was asking the question to tell me the question I was asking.
I'm gonna step in here, dude. If you have an issue with the moderation, go fill out a mod ticket. Otherwise,
I don't care about filling out a ticket. I'm talking to this guy.
How you feel. You
him for a source,
dude. And you can just go on mute. All right. So if you got a problem with the moderation, go fill out a mod ticket. Otherwise, let him mod you. Thanks.
Okay, great. Thank you for that.
Okay, so a source you asked for?
Yes.
Okay, yeah. So I will have to get back with you about that. I don't have the source with me right now where I can just pull it up and everything. But I just want you to answer this question.
So tell me what to Google. Tell me what to Google.
No. I don't know what to Google. I can't recall the source off the top of my head. I don't have it like saved or anything. I would have to find it.
Okay. All right.
But let me ask this question, and I want an honest answer. If it is true that we receive radio waves within the skip zones when it's supposed to be ducting off with the aurora and everything, tropospheric ducting. If we receive radio waves within that skip zone, do you have an explanation as to why we do?
No, I mean, I would have to look into it.
Yeah, so I'll try to find the source for you.
I don't know what to look into.
Yeah, so I'll try to find the source to you next time I jump on. And I'll probably DM it or something. But yeah. And I do have to go. So anyways, yeah, so to answer your things, yeah, there is rotation around a central point in the southern hemispheres. That's easily explained just through reflection off the dome, the firmament, and this you can easily just take the stars in the north, stars in the south, flip the stars in the south because obviously it's a reflection, it's flipped. Flip them, and you can literally line it up, find the patterns and everything are exactly the same. So it's reflection off of the firmament. That's what the stars in the southern hemisphere are, rotating around a central point. Sunsets, even on your model, it's not going behind the physical curvature of the Earth. It's an apparent horizon. So even in the model, as you call it, the sun sets not going behind the curvature of the Earth. So you can't say, oh, the reason sunsets happen is because it's going behind the curvature of the Earth. Not even the model. The globe Earth model is it going behind the curvature of the Earth. It's an apparent horizon. It's literally merging with the horizon, even in your model. So don't bring up sunsets. Don't bring up Eratosthenes. Don't bring up southern stars rotating the opposite direction around a central point. Like, those are stupid. You should probably do some more research because I hate it when people come on here who know nothing about the flat earth and they're acting arrogant.
Nice crash out there towards the end.
Yeah, but anyway, have you ever seen street lamps dropping down?
I've never seen streetlights going below the ground, no.
No. The sun doesn't go below the ground. What happens is it drops.
Have you ever seen
down.
a sunset? I mean, it really
yes,
sounds like you
I
haven't.
document them regularly.
Oh, yeah. Okay, so show me a close-up picture of a sunset, please.
I should show you that?
Well, I mean, I've seen a million of them. It sounds like you have.
Yeah, so have I. Okay.
Okay, so can you look up a picture of a sunset and show me?
Any sunset will do. Okay.
Okay, so how about I post one in the chat then?
Sure. Are you saying it would change size? Yeah. So what's happening?
I can't post pictures.
But
here.
Well, it wasn't letting me post pictures either. But so the sun doesn't go below the horizon. What happens is it drops down just like street lamps. Once it reaches the eye level, it's going to merge with the ground. Like if you have two car lights, in the distance they appear to be one.
Oh, okay.
Yeah, so it's merging.
Definitely look like it's merging right now in this picture.
Yeah, just don't bring up sunsets. Like that's.
Okay, thanks for that.
Oh wait,
you clearly know about sunsets. This is definitely merging into the ground. That's exactly what it looks like.
Are you being sarcastic?
No, definitely not.
Yeah, right.
Well, just like the
now. You're
you can do it now, man.
Like, what would your